Hi everyone, my name is Eulamai Tingco. I thank you all for being here to watch my presentation today. I ask you all, what does it really mean to be sustainable? Dr. Michael Cooney from the University of Hawaii at Manoa defines sustainability as a balance where humans and nature can coexist while meeting the needs of future generations. Think about it for a moment. What is one thing you do that's sustainable? For me, it's thrift shopping because it reduces waste. Concrete is everywhere, it's all around us. It's in our buildings, our sidewalks, our roads, but it also absorbs heat and contributes significantly to climate change. According to Gerardo Bandera, concrete production and rapid urbanization account for 7% of global carbon emissions, which is why the United Nations recognized it as a major environmental concern. With my background in civil engineering and design experience, I've learned about 3 different sustainable materials that can help reduce these impacts. Today, I'll discuss 3 sustainable alternatives. 1 is RCA, recycled concrete aggregates. 2 is LCB, low carbon binders. And 3 is self-healing concrete, SHC. The first one is RCA. So, according to the Federal Highway Administration, RCA is old concrete that is removed, crushed, and processed to replace virgin aggregate. This reduces landfill waste and conserves natural resources. Concrete is made of cement, water, and aggregates, and so aggregates make up the largest portion of the mix. Replacing them with recycled materials has a very big impact. An example of the usage of RCA is in the Colorado C470 Express Lanes project, where engineers reused all of the removed pavement to create RCA on site, and it made up 30% of the total aggregate in the new concrete, reducing hauling, material costs, and emissions. In a 2023 research study, we found that replacing up to 25% of natural course aggregate with RCA resulted in no loss of strength or performance and reduced concrete waste by about 40%. So, how do we remember RCA? It's like making new furniture from reclaimed wood. You can keep the quality while giving existing materials a second life. Now that we covered RCA, let's move on to LCB, low carbon binders. So cement acts as a glue in concrete, but its production contributes to roughly 8% of global CO2 emissions. Low carbon binders replace part of traditional Portland cement to reduce this footprint. The United Nations Industrial Development Organization classifies binders by emission from category E, the highest, to AA, which is near zero carbon. So, in a case study by Williams and Yang, we found that calcium silicate cement, CSC, reduced energy use by 46% and CO2 emissions by 35% compared to ordinary Portland cement. In a statistic, we found that limestone calcinated clay cement cost 25% less, and it decreased emissions by about 9% across the US cement sector. How do we remember low carbon cement or low carbon binders? Using low carbon binders is like upgrading a gas car to a hybrid. Save performance, fewer emissions. And finally, we move on to self-healing concrete, SHC. Self-healing concrete, or bioconcrete, is designed to repair small cracks automatically. According to TU Delft, this type of concrete contains dormant bacterial spores, which, when water enters a crack, the bacteria activates and produces limestone, sealing the crack naturally. So let's look at an example. Okay, from Drexel University, they created this biofiber system where spores are stored inside the tiny polymer fibers, and when the fibers broke, they released spores to begin healing from within. A statistic from ACI reported that self-healing concrete reduced maintenance costs by 50%. I think that's a win. And from an expert testimony, an expert, Dr. Hank Jonkers from TU Delft, explained that spores can remain dormant for up to 200 years, allowing repeated healing. That's such a long time. Here's the analogy once again. Self-healing concrete works like human skin. When you get a small cut, your body repairs it. So, what did we go over today? We went over RCA, low carbon binders, and self-healing concrete. I hope you all learned something new about how sustainable materials can supplement or improve traditional concrete. As an engineer, or as an inspiring engineer, being thoughtful about how we design and build infrastructure is essential for creating a more resilient and sustainable future. Mahalo again for coming out today, and have a wonderful evening/day. Bye bye.